Hello, my name is Joshua Clay, and I'm back again to talk about some of the difficulties in creating this Nerf Dart robot. In front of me are all the pieces that were designed and 3D printed in order to create this thing. A lot of my thought process involved here was modular components so that things could be created, iterated on, and changed without having to reprint the entire thing. I don't like the idea of wasting materials, so I wanted to use my best effort possible to make everything modular so that if I did need to make changes, I could swap out a part and swap it back in with a new part that had the change that I needed to make. A lot of the design process here is driven by asking myself, what is this thing? And my answer to that question is, this is a tank platform that drives around and utilizes a Nerf Dart turret. For that, I needed to be able to, first off, drive a tank platform around. Second off, I needed to be able to have a pan tilt mechanism in order to aim the Nerf Dart. And thirdly, I needed to have a working Nerf Dart system. So in order to complete this task, first off, I needed to pick components that would allow the motors to function, allow the pan tilt mechanism to function, and allow the Nerf Dart portion of the robot here to shoot. With all those components come a lot of wiring. Wiring, if you've built anything, can be a complete hassle. It ends up being a cobweb of grounds, voltage lines, signal lines, and every other wire that needs to be figured into this equation. For example, this is a motor controller for a single motor, and with this little component here, these three lines that are soldered on here are a signal line, a voltage line, and a ground line. Making sure I got that right. It in one into voltage and ground. So two of these lines here are going to the Arduino in order to program, so you can program forward or backwards so that it can tell the motor to run forward or backwards. And the third line is a ground line. Every component that interacts with the Arduino, this one in particular is being run by an Arduino Nano 2040. Every component needs to have a shared ground with the Arduino, and every component needs to have a way to communicate with the Arduino. With this component here, this is only half of the wiring. The other half here is a voltage and ground that needs to go to the motor itself that it's operating. And the other terminal here is a voltage and ground from the power supply. This unit here is driven off of a 12-volt power supply. So this plus 4 more wires is just for controlling one motor. So imagine you have 2 of these. That's just to make the chassis drive, plus the Arduino, plus the voltage and ground lines coming from the power supply. And then you add in a servo controller, which has its own pin setup here for controlling and sending data back and forth between the Arduino. Voltage and ground comes in here. So everything that you control has a ton of wires associated with it, and this becomes a hassle. And the more times I build something, the more I start to consider wiring something as important as building something. So whenever I design something, once I get this sort of movement and the sort of control part of it out of the way, I start to think about wiring, because wiring is just so important. Whenever you're putting something together, you inevitably have to take it apart. It just happens. You put it together, you figure out something isn't working quite the way that you thought it was going to work, and then you have to go through the hassle of troubleshooting that thing. So for this platform specifically, everything's built in pieces. So for the chassis, for example, I have these little dovetails, which is like a woodworking sort of cut, I guess you could say. So these dovetails allow these parts to come together and to align properly. If I can get it to align properly, like this, for example, so that when it gets screwed down to the base, here's the metal base, everything lines up successfully. So that's an important part. Also, if you see here, there are these channels that I've created. I have a red wire here so I can kind of demonstrate how this works. I have these channels. I'll put this in here and then actually, let me do it like this. This is going to be a little easier. So, for example, I 3D printed a channel here that allows some of my wiring to pass through here. This is a pretty large gauge, for example, so this would probably be for a 12-volt line, not necessarily for communicating information from an Arduino back and forth from a component to an Arduino. However, I like to keep the wiring cleanly, so this is a way to pass data from the front portion of the Arduino to the back portion, or from the front portion of the components to the back portion of the components. So this is a sort of channel here. These are channels here for wiring to go, just depending on what I'm doing. I like to sort of get as many wires as I can through these lower portions first, especially things like the motor controllers. So with something like this, I'm going to be running a lot of the motor controller wires through these in order to keep them trapped, because that's a base component, the motor controller. That's responsible for making this whole thing drive, and driving is a very core function of it. So that's sort of one of the things that I'm going to figure out first when I'm building something like this, is just getting that core functionality in of it driving, and then you start to build off of that. So for example, right here, this is I guess it would be the back portion here. I have these little nubs and these little mounting holes. Those are where, and that's why I have this electrical tape on the bottom here, because I had soldered my wires on to this component, and then it mounts. Here, I'll show you here. It mounts onto one of these bottom portions here, and then it has, the reason why I had those standoffs was so that it can put the motor controller a little bit higher so those wires can run underneath it, and that creates a cleaner sort of mounting position. And then these wires here can run through that side channel on this portion here. That just helps right off the bat make this a cleaner solution. So this is a base component, like I just talked about. This, I talked before about trays for electronics. These trays slide over top of those base components. So the idea here is this is a breakout board for an Arduino Nano. So my Arduino Nano RP2040 would lock into these black portions here, and then it gives me these screw terminals for running my data and ground into the Arduino. Like I said, everything needs to have a common ground. So this allows me to access these components a lot easier and slide them in and out to work on them. The biggest thing here that I wanted to accomplish was, again, I wanted all of these components to be very accessible, and I wanted the wiring to be logical, and I wanted it to make sense. I've built a lot of things where they can be a just mess of wiring, because I've always just sort of left the wiring consideration for last, because it's such a hurdle to make all the components and make something like this work. You don't always plan for all the wiring. Where's it all going to go? You're so excited to get the thing working that the wiring becomes an afterthought. So for me, when I've been building things lately and designing things, the wiring is almost important to me as the actual thing that I'm creating. So that's sort of my thought process with here, and you can see it through many portions of this design. For example, up here there are also holes, and these grooves are also so that I can run wiring along these top portions, and so that it can be ran high and out of the way of my component trays. So when my component trays slide in here, this wiring is high enough that it's out of the way. So it'll run high, and then it will run through like this, these top portions of the center configuration of the base. So very, very nice way to keep your wiring out of the way. I'm going to talk a little bit more about this base construction here. So all of these base pieces sort of connect. So this front portion is the same sort of way. It has these little dovetail cuts that connect like this also. So then this sort of forms my main base of this thing. This middle portion here has a top built in that slides on top. I'm not going to lock it down all the way because it becomes a little tricky to get it to pull it apart, because I want this to be tight. There are also screw holes here, so that once I tighten it down, I can put screws in it, the M2 screws, the hex head ones, so that everything locks into place. There's screw holes here, and there's also screw holes here, so it locks down in the center portion and the sort of outer edges portion in here, so it's extra secure. The reason why I created this separately was accessibility. I wanted to be able to put the whole base together, run my wiring, and before I run wiring to my pan tilt mechanism, I wanted to be able to run the necessary wires up through this center portion in order to drive them through the center portion. And the reason for this way of doing something is this Nerf Dart robot is going to pan and tilt. So if you look at this gear here, this gear, which is right here, pivots along this gear that is printed into the center. So it rolls, the servo pushes this gear and forces the turret to roll along it. And if I didn't run the wiring through the center, there's a chance that my wiring could get caught up in this gear action here. So see, it's like it glides along this gear here. So I sort of had to think about this almost like your nerves and all this running down your spinal cord. I wanted to figure out a way to keep all of the wiring for the turret portion, which is also the voltage, the ground, all of this important wiring for this turret. Voltage, ground for the voltage and ground for both of these motors for the flywheel cage need to run down through this center portion, here. The servos, there's one servo here which controls the pusher mechanism. That needs to run through the turret here and down into the center portion of the Nerf turret. So very important that these wires not get tangled up in the bevel gear, or the bevel gear is for the tilt, and the gear down here on the body portion is for panning. So that was my sort of solution there, was I wanted some accessibility to be able to run these through the center portion. So if you look here as well, I'm going to show you here. This, once it's assembled, a little wild here. We're gonna get there, I promise. This, once it's assembled, has, okay, there it goes. I have like a lower portion here that locks onto the edge of the metal frame. I'll talk a little more about that in a second. But this top portion also has the dovetails, and I have these little portions jutting out here so that this portion here, this extruded area, can lock into that. Actually, I'm gonna pull this off of here to get in the way. But this also has dovetails on it so that this joint locks into it. But so this, boom, it's locks onto there, right? So that it won't fall off, and it hides my electrical wiring and all my components. But it also has these dovetails to lock into the top center portion. So this whole thing sort of locks together. It has the dovetails on the bottom here where it locks at the base, the dovetails from the base section from here. And then it also sandwiches, once you put it on, it locks it sort of pulls everything together, which is a nice little feature. So even when I don't have all these screws in, everything still is just locking together based on the way that it's designed with these little grooves and all of that. So that's a nice little thing. So with the front portion also, that locks in nice and tight, has these little grooves here sort of stop the door from going any farther. And then these screws, little screws, go in the side here in order to hold it in. I only used 2 screws because once it's in there, it's not really popping out of there, and the screws will hold it enough. It's not going to like pop out of the bottom. And I did quite a bit of testing on that to make sure that that's the case, and it is. So that's the base portion. That's a sort of a good overview of this base. Let's move on to this side is the same. It has a little support for a motor controller. I think this was a previous print. I think in my newest ones, I don't have this here, but because I only needed 2 motor controllers, I tried to have a third motor controller control the flywheel motors so I could control the speed of the flywheel cage, but there is a stall voltage for these motors that it requires quite a bit of amperage to get these motors ran up. So I wasn't able to use those same motor controllers for the flywheel cage. If I want to be able to control the flywheel cage with PWM, with pulse width modulation, which is essentially a signal that turns the motors off and on at a certain spacing in order to make the motors go faster or slower. It does it like really fast. In order to do that, I would need a higher grade motor controller, which also takes up more space and it's also more expensive. So I opted to give the flywheel cage free rein to the 3S LiPo through a relay. So the relay is timed to turn on for so many milliseconds, allowing the flywheel cage full access to that 12-volt stream, and that is what is running it so far. So in order to back off some of the power of the flywheel cage, I can limit the amount of milliseconds that the relay is on for, and that would successfully create a situation where you can still shoot a dart, but it's not going to shoot as hard as it does currently. And that is something I need to do. I just haven't taken the time to play with some of the programming here. There's a lot of things I could do. I could add full auto, 3-round burst, 5-round burst, all kinds of stuff. So that's a fun little thing that I can do. I just haven't had the chance or taken the time to do it yet. So I guess another little thing here is that's kind of a cool thing. I used another sort of dovetail here for the light on my Nerf Dart robot. So it sort of slides on like that, boom, and it just holds itself. No need for screws or anything. And then my light just threads through here and has a little nut on the back of it that just tightens it down, and there we go. We got our light. Pretty simple. And it is tight, but it's not so tight that it'll fall off, and it's not so tight that you're gonna break it when it comes off. So pretty cool. Oh, this also, I'll hit on this. This is raised like this so that I can run wiring under it. So I talked about last time having a buck converter here, which takes my 12-volt line and converts it to a 5-volt line for my Arduinos, or for the Arduino, singular. I can essentially, I run my voltage lines out of here, and then I loop them around under here, and then through out this way. And then I feed all of my devices that need a 5-volt line off of that. So again, another way to think about the wiring, to think about how it's going to interact and it's going to wrap and how I'm going to keep it tidy. Put those down. So now we'll move on to the pan tilt mechanism. Pan tilt mechanism is a multi-piece situation here. It is more so than the neck portion. So this snaps into here. Excuse my shaky hands. I'm on a medication that makes my hand shake. So, and then this sits in here, and this is how this spins, like that. That's the sort of pan portion of this. So then the parts that go up that support the actual tilt mechanism and hold the Nerf Dart launcher is, these have little grooved section here. So this is grooved to hold that, and then there's 3 holes for M2 screws to go in there. Boom, holds it. It's nice and tight like this as it is. And this is where my servo for my, I guess it comes in this way. My servo for my pan goes here, for my pan mechanism that runs this gear that comes down here, and it pushes off of this base section here, if you remember. So that's what this section is about. This section runs the tilt portion, which is run off of a bevel gear. So if you look, I did the same sort of thing. I trapped this section with this piece, and then I have this square sort of extruded piece that runs into here, this section here, and it bottoms out so that once you push this in here, you can only push it so far. I'm not going to push this down here because I'm not ready to install this yet, but this is that's essentially how it assembles. And then the servo slides down in here, screws into these holes, and then that servo is what runs the bevel gear. Bevel gear is section here. This goes on the servo. It links up like this at a 90-degree angle. As the servo turns, it turns this section here. If you look at the Nerf Dart robot here, that's this section here. Here's the bevel gear. Here's the 90-degree angle. This gray section here is that section that I showed you that I wasn't going to install all the way yet. But this is just a cover here to hold it in. It doesn't really even need this cover because it's secured with 4, I think these are M3 screws. It's secured here with 4 M3 screws, but it's just a nice little touch, just covering that like that. And this side here is the pan section. And if you see here, this gear, maybe you can see the gear. Try it. This gear here is what runs along the base gear, like here, in order to push this sideways. So I had originally thought about pivoting this like a head, like a neck and a head. So it's sort of this mechanism where it was driving from a base. However, I needed that wiring to come through there, and I couldn't think of a good way to do that without adding more cost. So what made the most sense to me was using a little less than half of a gear, rotating sort of like this. Simple way to drive this mechanism. To drive this mechanism left and right. So, and this, I know it fell out, but that's because there are 4 screws, 4 M2 screws that would need to lock this in place. So it's keyed for this specifically, works only in one direction, well, 2 directions. If I turn it, it doesn't quite align. That was intentional. So have it successfully like that, boom, we're one piece here. This section locks the top of your bevel gear in place. The reason for that is if we jump over here to the Nerf Dart turret, this section here, I have these dovetails on each side, and that is for one side. Let's see, bevel gear has a little dovetail on the back of it, so it can, I may have to sand this. Yeah, it's pretty rough. I got this really tight so that I just have to do a little tiny bit of sanding to make sure that it slides and locks in place. So I got to do that sanding still, but the idea is similar to this one. This one goes on the other side. I think this one might be a little less snug maybe. Well, it's almost down there, but the idea is that this smaller extruded edge goes in this side here. This one's pretty tight also. I didn't really do my cleanup on this as I should have, but before showing you this, but it pops through this circle, this extruded edge, it rides on this, the rim of here, and then that is the same case with the bevel gear, rides on this, and then it is trapped in place with this guy here that makes sure that it doesn't hop out of here when the bevel gear pushes it. Just a nice way to make sure that it stays put. There's a lid here that just sort of goes over this other side. Hold on. Come down with that, keep that in place. But so that sits in there, and there's a nice little groove here that this little leg on here slides into to cover that. Again, I didn't clean this up so it doesn't slide in as nice as possible. All of these tolerances are relatively tight, especially for pieces that need to stay in place, so that I can just hit it with a little sandpaper, boom, check it, hit it with a little more, boom, check it, gold. All right, moving right along. That's the sort of pan tilt mechanism. Bevel gear turns it. The next portion is the Nerf Dart turret. Now, this is one of those situations where I wish I could have, and maybe there's a way, I haven't done a ton of investigation, I wish I could have made this more modular, more separated into a couple more pieces. However, it is responsible for taking the Nerf Dart magazine, comes in here, the flywheel mechanism, this is just the 3D printed portion without the motors or the wheels. So it is responsible for taking these parts. This sort of slides in like that and sits there. And then I have a pusher mechanism here. Everything with this portion, with feeding the dart into the flywheels, is extremely tight. It all needs to be very precise, especially when you're shooting darts fast. You need to line the dart. The dart needs to, as the magazine comes down here, the dart needs to line up perfectly with where it's being fed into. And then the pusher mechanism needs to align perfectly with the center back portion of the dart. I did build several of my own feed mechanisms, and what I found out is it's a pain. I did some feed mechanisms similar to, I found some World War II machine guns, I guess, and some that where there was like a feed bucket where you just drop all of the ammunition in it, and it sort of has a curved chute that all of the ammunition sort of feeds down into the feed mechanism. However, what happened when I tried that with a Nerf dart system is the rubber portion, the orange rubber portion on the front of the dart is heavier than the back foam portion. So as the darts fed into the feed mechanism, they started to tilt, especially if you were shooting fast. As fast as the darts were leaving here, the dart to replace it in position was starting to tilt and sort of get blocked up, I guess. Sort of, I don't know why I can't think of the wording here. Anyways, it started to get jammed, so not great. I tried a few different designs, and that's why I ended up just using Nerf darts, Nerf magazines, because they got it figured out. They have spent a lot of time. They have a great little package going there, so it just made sense to use what they have. Maybe eventually I will tackle that again, but for now I just rely on their feed system and try to focus my time and my interest and my energy on the things that are not completely difficult. maybe eventually. But so this, getting back to the flywheel system here, this is a guide for it that I designed here, because again, if you're shooting or if you're pushing these darts into here, the wheels are on the front. If it gets off even a little, it could come in just a tiny bit canted, and it could launch not straight, and it could hit the inside of the Nerf turret, and it could jam up, and we don't want that. So this portion here snaps directly over here and creates a guide. Well, I'm a little off. Creates a guide, but how it works is once I have the flywheel cage installed, this aligns through the front here and comes in perfectly straight here. I don't know what. It's probably a tolerance thing. Oh yeah, I'm a little tight, but so sort of like this. I have it extruded here in the front to accept this portion perfectly, and it perfectly aligns over top of where the flywheel would be. So that's how that works. This portion here, this back portion, this cutout, is where a tiny, like a micro servo, I think they call them, one of these tiny servos, slides into here with the servo arm inside of the Nerf dart portion. I have this little arm here slides over top of the servo arm that is included with the micro servo. It elongates it the exact amount that I need, and it interfaces with this pusher arm. So this pusher arm, as the servo rides along this groove, it pushes forward. So this is a guide, like with a rail. This is perfectly spaced to allow this arm, to ride along this portion here. I also have, there is a portion here on the inside of the Nerf dart turret that allows for this pusher to slide and travel in here. Again, this is a little tight, so I probably would need to ever so lightly sand the inside portion here, which is just part of it. So It just sort of slides and pushes here. And that's the mechanism here that pushes your dart into the flywheel section. And then this section here, this is perfectly designed to cover. Let's see here. Assemble this. It's pretty dead on. So like this. So this sort of rides along the rail here, and then the servo mechanism rides along this rail, and as the stroke moves forward, it pushes this forward. As it pulls back to its original positioning, it pulls this back out of the way. And that's essentially how the pusher mechanism works. So yeah, pretty fun. This hole in the bottom here is where my wiring comes up. I have these little routed sections. Let me run a wire through here so you can see it. So one second. So this here, this would be a smaller gauge of wire. This isn't for the flywheel wiring. This is for something new, which I still need to test out. Which, kind of a pain to get the wiring in. I guess I would use a tool originally, but this is essentially how it would work. So it's going to hold this wiring, and the reason why I have that there is so that it doesn't get in the way of the pusher mechanism, and it doesn't get in the way of the flywheel cage here. So the purpose of this is there is another. Let me run this out here. So there's another hole here. And yeah, this is for a smaller gauge wire because this is for a 5-volt line. This size of wire right now I have is for my 12-volt. However, the 5-volt would be quite a bit smaller, and I have this routed in a way so that I can run a 5-volt line outside of the Nerf turret. And the purpose for that is for an addition that I am adding. This is a FPV, first person view, camera holder. So this camera holder snaps down into here like this. Got a little hanger on there. And it takes a camera with a built-in VTX. This camera here is a Crazy Pony 5.8 gigahertz TX camera combo. So what it is a very tiny, which is pretty cool, very tiny FPV camera, and it has a built-in VTX transmitter. So this is your camera and your transmitter all in one. These tiny little wires, these are for your 5-volt line. It actually might even work with 3 volts, 3.3. I'll have to look it up. But the idea here is that I put my little camera here, boom. It would hook up wiring wise to here, so I got electricity to it. And then I got a camera. And with that camera, I have a receiver that I have, so I'm making a cell phone holder. So the whole cell phone would be held right here at the top so you can look at the screen. Transmitter plugs into the USB-C on your cell phone. It would mount on the back of the holder. And then you have a first-person view of your Nerf Dart platform. So when you aim it with your pan tilt mechanism, you can see what it sees. So you can drive it around the house, look at your target, boom, shoot it. One of the things that I wanted to do with this was set up Dixie cups throughout the house and put like point values on it, and do like a little contest, have a buddy over or whatever, have 20 points on a Dixie cup, 10 points, you know, the higher points are in a more difficult location, but allow like 3 minutes. You have 3 minutes to drive it through the house, shoot as many Dixie cups as you can, get as many points as you can. So could be a fun little game to play with something like this. That was sort of one of my thoughts. So yeah, again, the cool thing about building this modular, I had sort of planned this area for a camera because I had built one of these before something like this, not this exact one by any means, a dirtier Nerf Dart gun, something that wasn't, or gun, turret, something that wasn't as well thought out as this. I had a camera on that one, and an analog FPV camera, and it was awesome. So when I was designing this, I always sort of had the intention of building the camera, but I wasn't quite sure how I was going to do it. So what I did is I left this door here for the explicit purpose of being able to build some sort of add-on that would clip into here and be able to hold it. However, what I didn't do on this other version, the version I'd shown you before, is I didn't have a nice, tidy way to run my wiring. That was something that I hadn't thought about. I hadn't thought about how the wiring, I figured I could just run the wiring up through this center portion, but I didn't think about the fact that there is a lot happening in the center here with the pusher mechanism pushing the darts into the flywheel cage. So this was my nice little solution here to keep the wiring hugging along this outside wall and then run it up outside of the Nerf Dart platform so that it can hook directly into my camera like that. Boom. Perfect. So pretty excited about that. So with this build here, that is what I'm going to be doing, is hooking up and installing that analog camera, printing out the cell phone holder for the controller with the receiver holder also for this. These are things you can get off of Amazon offline for pretty cheap. I can't remember exactly how much it was, but it definitely didn't break the bank by any means. It was, 10, 15 bucks, something like that. So pretty cool. This is the door, I guess, for this. So covers the whole thing up, screws in, ready to rumble. It's a little big here because I have my bevel gear that comes on here, goes into place. Sweet, awesome, golden. For the servo here, I got a little chunk here that slides over it, covers it, protects it. Just a little cleaner also, a little more polished looking, instead of having a blue transparent plastic servo. I mean, it's not the worst look, but I just like, since I had gone this far, I like to have everything kind of tidy and nice looking. So the other things that I needed to do was with the base here. I talked about this last time, the metal base. Cheap on Amazon, tank tread base, 20 bucks. I think I checked Amazon, it was $23. I think it used to be cheaper, but with tariffs and all that stuff, pretty sure this is a Chinese thing, so it's like 23 bucks. One of the situations that I ran into is the hole for these fixed wheels, because there's the motor driven wheel with the sprocket on it that interconnects with the chain, and then there's like a free standing wheel. It is the wonkiest thing. I don't understand, and I've had other people run into this also, and we talked about it, a buddy of mine, Sir Walter, and it's floppy, and I don't get it. Before I had solved this problem, it would just, the tank tread would just come off. It was this, how they had built this is it's misaligned with the tank tread with the front sprocket, so it's at an angle, so it sort of, the more forward momentum you give it, the more it works itself off, which is mind-numbing. I don't understand how that even made itself into a product at that point. I don't understand. Don't get me started. So the other problem is the metal here on the platform itself is very thin. So once you screw this together, it's very like wibbly wobbly, floppy, not good. So what I did was I 3D printed a sort of disc insert that I made for this. Let me get this part here. So it has a little nub that sticks into this, so it fits directly into this hole, Sorry, one second. It's supposed to fit directly into this hole. Maybe I'm doing it in the wrong one. Let's try this again. Directly into this hole? Sure it does. Well, it usually does. I don't know what's going on here. Now I'm confused. I literally just had it in there. Anyways, oh, you know what? Let's try this one. I have a couple different sizes that I was experimenting with. This one. Boom! Perfect. Look at that. Perfect. So the idea here is I've created more depth to where this wheel comes through. And with more depth, this is tight, so it screws down into here. Again, another way to strengthen that. So with this more depth here, it gives it more substance to grab onto it. It's more of a, and what is the horizontal sort of strength to it. So it's not, instead of being held by like something this thin, so it has a lot of wiggle room, now it's held by something big enough to like keep it straight, keep it steady. So that was sort of my solution there. I have the files for that if anybody uses this platform and for your own project or something, I would happily send you my solution here because it's annoying. So fixing that is a good thing. Another thing that I wanted to do that I sort of didn't do yet is that there's these little LED bars here. It is a WS2812B. WS2812B. This is an LED stick that has 8 LEDs. What I did is I created a portion on the bottom of the front and the back that will fit one of these LED strips. There you go. I have 2 little holes for screws, but my point here, the purpose here was so that this, oops, I flung that, but that's fine. So this tank tread platform sits on here, and then my LEDs sit on the bottom. So then I can have some front and rear LEDs shining, doing light shows on the floor or whatever as the tank tread is running around, as the Nerf turret thing is running around. Pretty cool. Something I haven't gotten to yet. Another thing, just like the FPV camera, that I wanted to do, just to add a little more interest. Oops. My plan there was, you know, as you're aiming, getting ready to shoot, maybe it has like a slow build up, sort of like Knight Rider. Maybe I'm showing my age there, where it's like a cool little light show, and then when you're shooting, for example, it's like flashing red or something, something kind of cool like that. Yeah, I think that's the biggest stuff that I wanted to cover. The next things I'm going to do is go through, I'm going to build this thing and wire it. The wiring portion is pretty wild. I did dig up some photographs of when I wired this one. I appreciate your time. Like and subscribe, leave a comment if I left anything out, or if you have any questions that you would like me to cover. I will be back again shortly. Thank you.